Here are 26 practice problems on quadratic functions. As per usual, I'll link these questions and the answer key in the description, so if you want to work ahead, you can go ahead and do so. But if you need a little bit more help, I will be going through every single question. Or if you need further clarification, feel free to ask me. Anyways, let's get started with question number 1. The quadratic function h is defined as shown. In the xy plane, the graph of y equals h of x intersects the x-axis at those 2 points, where t is a constant. What is the value of t? Let's go ahead and put that equation into desmos. Now they're asking us to find the x-intercepts. We have one at 0, 0, but they already mentioned that. And then our second one is at 8, 0. So that means that t will be equal to 8, and our answer will be D. Question number 2. A machine launches a softball from ground level. The softball reaches a maximum height of 81.84 meters above the ground at 1.8 seconds, and hits the ground at 3.6 seconds. Which equation could represent the height above ground, h, in meters of the softball t seconds after it is launched? So here it says the softball reaches a maximum height of 51.84 meters at 1.8 seconds. Now whenever it says maximum height, that means it's gonna be the vertex. So we could represent this as a point like this, where the seconds is the x value, and the height is the y value. Now if you know the vertex formula, then you could probably instantly figure out that your answer would be D, but you could also just put in desmos to make sure. Alright, so I went ahead and put it in. I changed h to be y and then t to be x. And you notice that the vertex is at 1.8, 51.84. Now it also says it hits the ground at 3.6 seconds. So at 3.6 seconds, its height is 0 meters. And if we go ahead and check that, it does have an x-intercept at 3.60. So once again, you could just know the vertex formula and note that hk is your vertex, or you could just put all of the answer choices into desmos and find out if the points match. Question number 3. Now a trick that I like to use on these types of word problems is to label what our variables mean. So let's go ahead and start reading. The revenue f of x in dollars that a company receives from the sales of a product is given by the function f above. So we know that the revenue is going to be f of x. So f of x, or y, is equal to the revenue. Let's keep reading. Where x is the unit price in dollars of the product. So we know that x is the unit price. The graph of y equals f of x in the xy plane intersects the x-axis at 0 and a. What does a represent? So here they tell us there's x-intercepts at 0 and a. So we could rewrite that as points 0, 0, and a0, because remember, x-intercepts will have a y value of 0. Now they ask us what a represents, so let's go ahead and bring this down. We know that a will be our x value, and 0 will be our y value. We also know that x is the unit price, and y is the revenue. So if we go ahead and put this all together, the unit price of $8 will result in a revenue of $0. And the answer choice that says that is C. Question number 4. In the given quadratic function, a and c are constants. The graph of y equals f of x in the xy plane is a parabola that opens upward and has a vertex at the point hk, where h and k are constants. If k is less than 0 and f of negative 9 is equal to f of 3, which of the following must be true? Now must be true is going to be a very important thing that you need to keep in your mind. First up, let me go ahead and sketch a little graph. They say that f of negative 9 is equal to f of 3. And what this means is that the x values of negative 9 and 3 have the same y values. So if we were to represent this as points, it would look something like this. Now theoretically, let's just say they had a y value of 3. And let's go ahead and graph this. Let's say this is negative 9 and this is 3, and then they have the same y value. Then they tell us it has a vertex at the point hk, where k is less than 0. So the y-coordinate of the vertex is less than 0, which means it's negative. So it has to be somewhere down here. Now you should also note that the vertex is of course in the center of the parabola. So it's going to be somewhere in between these 2 points. let's just say that this right here roughly is the center, and of course the y value is negative. Lastly, they tell us that the parabola opens upward, but based on how we drew this, it already kind of looks like that, so I'll just go ahead and connect the dots real quick. Okay, now let's look at our answer choices. We have c is less than 0 and a is greater than or equal to 1. First, let's prove if c must always be less than 0. Now if you look at our equation here, c is going to be this last number, and that last number will always be your y-intercept. The reason for this is because your y-intercept is when your x value is 0. So if you set x equal to 0, then these two would just cancel out, and then you would only be left with c. So once again, c is the y-intercept. Now if we look at our graph that we currently drew, our y-intercept is indeed less than 0. It is negative. However, if we were to redraw the graph where it still meets all the requirements that these 2 points must share the same y value, k must be less than 0, and the parabola must open upwards. Alright, so I went ahead and redrew the graph, and would you not say it still meets all the requirements? First up, does the parabola open upwards? Yes, it does. Second, is k less than 0? Yes. The y value of the vertex is negative. And lastly, is f of negative 9 equal to f of 3? Or do the points at negative 9 and 3 share the same y value? They do. This time, our y-intercept is positive. This means that the y-intercept doesn't always have to be negative. It could possibly be positive. So 1 isn't necessarily always going to be true. And then secondly, a is greater than or equal to 1. So here in our equation, a is going to be this number right here. Depending on how small or big it is, it could control the width of the parabola, so how big the parabola opens. But more importantly, if a is positive, then the parabola will open upwards, and if a is negative, then the parabola will open downwards. Now we know that this parabola has to open upwards, which means that a must be positive. However, a number that's positive just has to be greater than 0. It could be 0.01, it could be 0.5, it could be 0.67. It does not have to be greater than or equal to 1. That means that a does not always have to be greater than or equal to 1. So which of the following must be true? Well, under the right circumstances, none of them have to always be true. So the answer will actually be D, neither 1 or 2. Alright, I know that was a really long explanation, so I want to restate some things and hopefully that will make it easier to understand. Now in the question, they ask us which of the following must be true. This means that in every single equation, c always has to be less than 0, or the y-intercept always has to be less than 0. However, we just proved here that the y-intercept can be greater than 0. So this doesn't always have to be true. Secondly, a is greater than or equal to 1. Well, we know that in order for a parabola to open upwards, it just has to be greater than 0. It doesn't always have to be greater than or equal to 1. So this doesn't always have to be true. Therefore, neither 1 or 2 would be our answer, because neither of those must always be true in order to create a graph that opens upward, has a vertex at the point hk, where k is less than 0, and where f of negative 9 is equal to f of 3. Question number 5. The function g is defined by that. For what value of x does g of x reach its minimum? Let's go ahead and plug f of x and g of x into desmos. So there's f of x, and here's g of x. Now we have two graphs on desmos, so if you want to turn one of them off, you can just click the colored circle to the left of the equation, and now we only have one graph. Here's the minimum, and they're asking us for the x value, so here the x value at the minimum is negative 13, so our answer will be A. Question number 6. A quadratic function models a projectile's height in meters above the ground in terms of the time in seconds after it was launched. So basically that just means that the height is your y value and the seconds is the x value. The model estimates that the projectile was launched from an initial height of 7 meters above the ground. So here they tell us it's an initial height of 7 meters. That means 7 meters will be our y-intercept. Whenever they say initial, that's going to be the y-intercept. So that point would be at 0, 7. At 0 seconds, it had a height of 7 meters. Let's keep reading. And reached a maximum height of 51.1 meters above the ground 3 seconds after the launch. Here they tell us it's a maximum height. And whenever you have a maximum or minimum height, that's going to be the vertex. They tell us this vertex is at 51.1 meters and 3 seconds. We know our seconds is our x value, and our height is our y value. Let's continue reading. How many seconds after the launch does the model estimate that the projectile will return to a height of 7 meters? So they give us a height of 7 meters, and they're asking us to find the time for that height. One thing you should know about parabolas are that they're symmetrical. So since these two have the same y value, that means that the distance from this point to the vertex is going to be as the same from the distance from this point to the vertex. So if you were to draw it on a graph, this point right here would be 0, 7, this point right here would be your vertex, and this point right here would be x7. And once again, the distance from here to the vertex is the same as the distance from the vertex to here. So the distance from 0 to 3 is of course 3, so that means that the distance from 3 to x will also be 3. So 3 plus 3 is 6. That means the value of x will be 6. Question number 7. The given equation relates the variables x and y. For what value of x does the value of y reach its minimum? Let's go ahead and put this equation into desmos. Alright, so here's our parabola, here's our minimum, and they're asking us for the x value, and the x value at the minimum is 7, so our answer is 7. Question number 8. What is the minimum value of the given function? Let's go ahead and put this in desmos. Alright, here is our parabola, and whenever they ask you for the minimum value, if they don't specifically say, like in the last question, for what value of x, and they just say minimum value on its own, that means they're asking for the y value. So here at our minimum, the y value is 55. So the minimum value would also be 55. I don't know why I wrote my 5s like that, but that means our answer is B. Question number 9. The function f is defined by the given equation. For what value of x does f of x reach its minimum? Let's go ahead and put this function into desmos. Alright, here is f of x and our parabola. Now they're asking us for the value of x. So here at our minimum, the value of x is negative 2.5. And they want our answer to be in fraction form, so what you can do is just type in negative 2.5, and then to the blue blocks on the left, click that fraction, and you get that the fraction form would be negative 5 over 2. That means our answer will be D. Question number 10. The function f is given. Which table of values represents y equals f of x minus 3? Let's go ahead and type both of those equations into desmos. So there's f of x, and then we also want to type in our second equation, y equals f of x minus 3. Now all of our answer choices are tables, so what you can actually do is click this gear icon right here, and then in our y equals f of x minus 3 equation, click the table, and they went ahead and made a table for us. Now if we look at all of our answer choices, the x values are negative 6, negative 5, and 4. So let's go ahead and type those in. Negative 6, negative 5, and 4. And we get that for all three of those x values, the y values would all be negative 3. So the table that matches this is B. Question number 11. Here we have a word problem, so I'm going to label our variables. The equation gives the estimated stock price, Y, in dollars for a certain company X days after a new product launched. So we know that Y is the stock price, and we also know X is the days after it launched. Let's keep reading. Where 0 is less than or equal to X, which is less than or equal to 20, which statement is the best interpretation of xy equals 183 in this context? So here we have the point 183, where 1 is our x value and 83 is our y value. We also know that x is the days after launch and y is the stock price. Alright, so I went ahead and rewrote it for fun, so if we go ahead and put this all together, one day after launch, the stock price was $83, and the answer choice that says that is C. Question number 12. The function f of x gives a metal ball's height above the ground, f of x in inches, x seconds after it started moving on a track. So here we note that f of x, which is y, is the ball's height above the ground, and x is the seconds after it started moving. Let's keep reading. Where 0 is less than or equal to x, which is less than or equal to 10. Which of the following is the best interpretation of the vertex of the graph of y equals f of x in the xy plane? They're asking us for the interpretation of the vertex. So first up, we have to find out, well, what's the point of the vertex? There's two ways you can do this. The first way is that you could recognize that they give us the function f of x in vertex form. Our vertex would be hk, or 7, 3. Now if you don't want to memorize the vertex form, you could always just put it in desmos. So I went ahead and put our function into desmos, and you notice that the vertex is at 7, 3. Now the thing you should remember about the vertex in word problems is that the vertex will always be the minimum or the maximum height. And here if we look at a parabola, I think it's kind of obvious that our vertex is the minimum. That means that our answer will either be A or B, because they're the only ones that mention minimum height. And then as for which one, well, we know our y value is 3, so the height is 3 inches above the ground. That means our answer will be A. Question number 13. For the quadratic function f, the table shows 3 values of x and their corresponding values of f of x. Which equation defines f? So here they're asking us to write an equation, and we can do that by just using regression in desmos. So first up, you want to click this plus sign up here, and then insert a table. Then you want to type in all of the points, so negative 110, 0, 14, and 120. Then the regression equation for quadratic regression is y1 tilde ax1 squared plus bx1 plus c. And we get that our equation would be y is equal to 1x squared plus 5x plus 14. That means our answer will be D. Question number 14. In the xy plane, a parabola has a vertex at that point and intersects the x-axis at 2 points. If the equation of the parabola is written in the form of that, where a, b, and c are constants, which of the following could be the value of a plus b plus c? First up, they tell us that the parabola has a vertex at 9, negative 14, and intersects the x-axis at 2 points, so it has 2 x-intercepts. So theoretically, we can say it intersects the x-axis at this point and at this point. Now you should also note that a parabola is symmetrical. This means that the distance from point A to the vertex is equal to the distance from point B to the vertex. They both have the same distance in between, and we can call this distance D. Now to solve the rest of this problem, we can use regression in desmos. So first up, you want to click this plus sign up here to insert a table. Now to do quadratic regression, you need at least 3 points. And you think that, oh, they only give us 1 point, the vertex, which is 9, negative 14. But we do know 2 more points. We know point A and point B. So to represent point A, we know that point A is to the left of our vertex. So we could represent that as 9 minus D. 9 minus this distance right here. And then for point B, we can represent that as 9 plus D. 9, which is our vertex, plus this distance right here. Now once again, the reason we're doing minus D and plus D is because we don't actually know where the x-intercepts are. All we know is that one will have to be to the left of the vertex, so the x value of our vertex is 9, and we have to subtract some distance from it. And now we know the other x-intercept is to the right of the vertex. That's why we're taking our x value of 9 and then adding some distance to it. We know that both of the x-intercepts will be the same distance from the vertex, so that's why we can represent them as one variable D. And finally, they're both x-intercepts, which means that both of their y values will be 0. Next up, the equation for quadratic regression is y1 tilde ax1 squared plus bx1 plus c. So basically, the same equation that they gave us, except you put a 1 in front of all of the x's and the y's, and then change the equal sign to a tilde. They're asking us to find the value of a plus b plus c, so let's also type that in, a plus b plus c. And then finally, we need to set d equal to some value, so we can just set d equal to 1. Now this will also make a slider for us, so we can test out multiple different values. Right now d is set equal to 10, and a plus b plus c is equal to negative 5, and that doesn't really look like any of our answer choices. If we set d equal to 1, then a plus b plus c is equal to 882, so once again that's definitely getting way further away from our answer choices. And then if we set d equal to negative 10, then a plus b plus c is negative 5 again, so the same as when we set it to positive 10. Now let's try setting d to be larger numbers. So next to this blue dot here, I'm going to click on the negative 10 and set this equal to something like negative 1000. Now if we keep making d smaller, you notice that the value of a plus b plus c will get infinitely closer to negative 14. However, it will never actually reach negative 14. It will always just be slightly greater than negative 14. Now if I made it equal to like negative 10,000, then the decimal would probably be something like negative 13.99999, whole bunch of 9s. So yeah. Now let's go the opposite direction. Let's set d equal to positive 10,000. And you notice the same will still apply. It will infinitely get closer to negative 14, but it will never actually be negative 14. So what we can get from this is that the value of a plus b plus c will always be greater than negative 14. The only answer choice that satisfies that requirement is D, because negative 12 is greater than negative 14. Alright, that was a really roundabout way of explaining this problem, but you could have also just realized that, well, negative 14 is the minimum because the vertex is at 9, negative 14, and there are 2 x-intercepts, which means that no matter what, the parabola must open upwards. So that means that negative 14 will be the smallest y value in our parabola. And if we theoretically try to find the value of y when x is equal to 1, we would get this equation. F of 1, or just substituting 1 in for x, is equal to a times 1 squared plus b times 1 plus c. And anything times 1 is just itself, so we would get this is equal to a plus b plus c, which is also what we're trying to solve. Oh my goodness, it's the same thing. Anyways, this means that the y value when x is equal to 1, so theoretically we would say this is when x is equal to 1 right here, this y value would be the value of a plus b plus c. And if you notice, that y value is definitely greater than negative 14. That means that our answer must be greater than negative 14, so negative 12 would have been our only possible answer. Question number 15. The table above gives selected values of a polynomial function p. Based on the values in the table, which of the following must be a factor of p? Now if you go ahead and look at our answer choices, you'll notice that all of them are in this factored form, which is also known as intercept form. And the thing about intercept form is that when you set them equal to 0, so if I were to set x minus 3 equal to 0, then you would actually get the x-intercept, x equals 3. So basically, the factors here are just the x-intercepts. So if we go ahead and look at our table, we have 2 x-intercepts, one at 2, 0, and one at negative 1, 0. And your x-intercepts are of course when your y value is 0. Now if we go ahead and rewrite those intercepts into intercept form, or factored form, we would get, and you notice that they're the opposite sign, that's positive 1, but here it's negative 1, this is negative 2, and this is positive 2. Because once again, if we set this equal to 0, we would get the x-intercepts of negative 1 and positive 2, which of course match our table. Anyways, I'm sure you already know all of this because we all passed algebra, of course. Anyways, our answer will be D. Question number 16, we have a word problem, let's label those variables. The height in feet of an object x seconds after it is thrown straight up in the air can be modeled by the function h of x. So here we know that the height will be h of x, or the y value, and the seconds will be the x value. Let's keep reading. Based on the model, which of the following statements best interprets the equation h of 1.4 equals 1.64? You should note that this number in here is replacing x, so 1.4 is our x value, and then this number is our y value, so 1.64 is our y value. So if we go ahead and put this all together, 1.4 seconds after the ball is thrown straight up in the air, it reaches a height of 1.64 feet. And the answer that says that is A. Question number 17. The function f is defined by f of x. The graph of f in the xy plane is a parabola. Which of the following intervals contains the x-coordinate of the vertex of the graph of f? Let's go ahead and put that equation into Desmos. Here's our parabola, and here is our vertex. The x-value of the vertex is -2. And the answer choice that has -2 in its interval is B. Question number 18. An engineer wanted to identify the best angle for a cooling fan in an engine in order to get the greatest airflow. The engineer discovered that the function above models the airflow, f of theta, in cubic feet per minute as a function of the angle of the fan, theta, in degrees. According to the model, what angle in degrees gives the greatest airflow? Alright, that was a whole bunch of yap, but basically what they're trying to say is, here the angle theta, that's going to be our x value. And then the airflow, f of theta, is going to be our y value. So long story short, they're asking us what value of x gives the greatest value of y. Let's go ahead and just put this equation into Desmos. Instead of theta, I'm going to just put x. Alright, I went ahead and put it in. Here is our parabola. And the x value that gives the greatest y value is 27. So that means our answer will be 27. Now you also could have figured this out because this equation is in vertex form. So you would know that hk is your vertex, and since there's a negative sign here, that means the parabola will open downwards and your vertex will be the maximum value. So of course 27,880 would be your vertex, and then you would know that 880 is your maximum value and the x value that gives that is 27. Question number 19. We have a word problem, let's label those variables. The function above models the height h in feet of an object above ground t seconds after being launched straight up in the air. So here our height h will be the y value, and the t seconds after being launched straight up in the air is our x value. Let's keep reading. What does the number 72 represent in the function? So here we have an equation in the form of ax squared plus bx plus c. And in this form, your c value will always be the y-intercept. So here 72 will be our y-intercept. And in word problems, your y-intercept will always be that initial value. That means our answer will either be A or C, because they mention initial. Now for B and D, they say maximum, but you should remember your maximum value would be the vertex, not the y-intercept. Alright, then of course your y-intercept is going to be a y value, and our y value is the height. So of course it would only make sense it would be the initial height, not speed. I mean, not once is speed ever mentioned in the entire problem, so it wouldn't make sense to choose that anyways. Our answer is A. Question number 20. A quadratic function models the height in feet of an object above the ground in terms of the time in seconds after the object is launched off an elevated surface. So basically, the height is going to be the y value, and then the time is going to be the x value. The model indicates the object has an initial height of 10 feet above the ground. We know that anything initial will be our y-intercept, so there's a y-intercept at 10. Let's go ahead and write that down as a point. It would be 0, 10. Let's keep reading. And reaches its maximum height of 1,034 feet above the ground 8 seconds after being launched. We know that anything dealing with the maximum is going to be the vertex, and this vertex is at 1,034 feet and 8 seconds. We know our time is going to be the x value, so 8 would be the x value, and then the height is the y value, so 1,034 feet will be the y value. Let's continue reading. Based on the model, what is the height in feet of the object above the ground 10 seconds after being launched? So we're trying to find the height, which is the y value, and we know the x value is 10 seconds. So let's go ahead and write that down. 10y. Alright, so I want to solve this problem using quadratic regression in Desmos. However, the problem with that is that we need at least 3 points, and right now we only have 2. The y-intercept and the vertex. But we can solve for a third point, using the fact that parabolas are symmetrical. So if we had a point that had a y value of 10 as well, we know that the distance from the y-intercept to the vertex would be the same as the distance from the vertex to this second point over here. And the reason for this is, of course, they have the same y value. And a parabola is symmetrical, so the distance would be the same. It would look something like this, where they're both at y equals 10, and here's the vertex. You know what I'm saying. Alright, so the distance from the y-intercept to the vertex is 8. You added 8 to go from 0 to 8. So that means the distance from the vertex to our second point here will also be 8. 8 plus 8 is 16, so that means the x value of this point will be 16. Now that we have 3 points, let's go ahead and solve for this using regression. First, you want to click this plus sign up here to insert a table. Then you want to type in our 3 points, 0, 10, 8, 10, 34, and 16, 10. Then the equation for quadratic regression is y1 tilde ax1 squared plus bx1 plus c. And finally, we're trying to solve for the y value when x is equal to 10. So we can just type in x equals 10, and then if we go ahead and scroll on our graph, eventually we'll get there. So here on a parabola, when x is equal to 10, the y value is 970. So that means our answer is 970, or C. Question number 21. The given equation defines the function f. For what value of x does f of x reach its minimum? Let's go ahead and plug that into desmos. Alright, so here's our function, and here is the vertex, or the minimum. They're asking us for the x value at the minimum, and here the x value is 6.25. So our answer is 6.25. Question number 22. The function h is defined above where a, b, and c are integer constants. If the zeros of the function are -5, 6, and 7, what is the value of c? Alright, so let's go ahead and write those as points. We know that the zeros on a graph are when y is equal to 0, so we could write this as -5, 0, 6, 0, and 7, 0. Now to solve for c, we can actually use regression, so let's go ahead and click this plus sign right here, insert a table, and then put in these points, -5, 0, 6, 0, and 7, 0. This time, however, I think you can tell, but it's not a quadratic, so we won't be using quadratic regression. Instead, what we want to do is take this equation and put it into desmos. Now instead of h of x, we can just type a y, and then after this you want to put a 1. Instead of an equal sign, you want to put a tilde, and from now on, after every single x, you want to put a 1, like that. Alright, so I went ahead and typed it in. There's 1s after every single x, and then we get that the value of c is equal to 210. So our answer is 210. Question number 23. The function f is defined by the given equation. For what value of x does f of x reach its minimum? Let's go ahead and put this in desmos. And here is our minimum, and the x value is -7. So our answer is -7. Now you could have also noticed that the equation they give to us is in vertex form. So the vertex would be hk, which is -7, 4. And of course, the minimum is always going to be the vertex, so the x value would once again be -7. Question number 24. An object is kicked from a platform. That equation represents this situation, where h is the height of the object above the ground in meters t seconds after it is kicked. So here, h, our height, is going to be our y value, and then t, our seconds, is going to be the x value. Which number represents the height in meters from which the object was kicked? So here they're asking us to find the initial height, and anything initial will always be the y-intercept. And you should know, when an equation is in the form of ax squared plus bx plus c, the y-intercept will be the c value, and here our c value is 9. So the height from which the object was kicked, or the initial height, is 9. Now you could of course just put this in desmos. I'm going to substitute h with y and t with x, and you would get that the y-intercept is at 9. Question number 25. The quadratic function above models the height above the ground, h, in feet, of a projectile x seconds after it had been launched vertically. So here, the height above the ground, h, is going to be the y value, and then x seconds after it had been launched will be, well, our x value. If y equals h of x is graphed in the xy plane, which of the following represents the real-life meaning of the positive x-intercept of the graph? So they're asking us what the x-intercept should mean. And you should know that the x-intercept is when y is equal to 0. So, x of course is going to be the time after it had been launched vertically, and then y is going to be the height. So the x-intercept would be the time when the height is 0 feet. That means our answer will be D. When the projectile hits the ground is the same as having a height of 0 feet. Question number 26. The function f is defined by the given equation. For what value of x does f of x reach its minimum? Let's go ahead and put that in desmos. Here's our equation and our parabola. They're asking us for the value of x when it reaches its minimum. Here's the minimum, and the value of x is negative 1.5. Now negative 1.5 isn't one of our answer choices, but we do see fractions, so what we can do is type in negative 1.5, and then in the blue box to the left, click on the fraction, and we get that the fraction form would be negative 3 over 2. So that means our answer will be D. Alright, that was 26 practice problems on quadratic functions, and as you can tell, most of these you can just easily put into desmos and instantly find out. Like this question right here. Wait, I just realized this question has TikTok colors for the ID. Anyways, there were some questions that were pretty conceptual. Like this question was pretty long and pretty challenging. And this one right too, this question has to be the worst question on here. Like, why is this even a question? Anyways, hopefully you understand, and a few things that you should remember are that whenever you get word problems like these, it's really important that you pay attention to what y and x equal to. So label your variables basically. Now you don't actually have to write it down, but make that mental note. And then in questions like these, it'd be pretty useful if you know the vertex formula, but it's not a problem just putting it in desmos. You should also note that the maximum height will always be the vertex. You should note that the minimum will also be the vertex, so the maximum and the minimum are the vertexes. For questions like this, make sure you know how to do quadratic regression. Make sure that you know that your c value is the y-intercept, and your y-intercept will always be that initial value. And finally, it's definitely going to be very helpful to know that a parabola is symmetrical, so if 2 points have the same y value, they'll be the same distance from the vertex. Alright, that's going to be it. Good luck studying, and I'll see you.